Hello, everyone. We first would like to thank you all for being here and letting us share our approach on of having an effective cross-DAG dependency in Airflow. First, we'll go through the motivation that led us design this whole solution. Then we'll share some of the spikes we've done throughout the process. Finally, getting into the solution itself. In the end, we'll do some final considerations and, of course, open for any questions you may have. Okay, so before anything, we'd like to give you guys a little bit of context of what is QuintoAndar. So QuintoAndar, which can be roughly translated to fifth floor, is a company created to simplify the lives of those looking for a new home. And since the beginning, we are at the center of a I would say, global transformation of the real estate industry. So we have digitalized the whole process, so no one has to go through a tedious and bureaucratic one to find your next home. And we are currently at 29 cities in Brazil, and we actually want to expand internationally one day. So on the inside, we have, along with several product and operation teams, a data area that is responsible to support decision making. And we kind of subdivide that area in data engineering, data analytics, machine learning operations, and data science teams with dedicated focus. And speaking more of the data engineering side, the teams are responsible for designing, for deploying, and for maintaining data pipelines so we can provide the support for the decision-making process. And, well, we accomplish that by using Apache Airflow. Right now at QuintoAndar, we use GCP's Composer to leverage the entire Airflow infrastructure, which contains approximately 100 DAGs with tasks varying from 4 to 100 per DAG. And all that gives us around 2,500 daily executions. And we have those numbers kind of because of the design of the whole pipeline. I mean, we understand that because there are sources, internal and external ones, databases and APIs that have specificities, their own constraints for throttling, for session limits, and, well, for much more. We have separated each DAG for a single source. And that gives us more than just an overcome of those constraints. It gives us flexibility, specific schedule intervals, optimized resources, and more. And another advantage of splitting a huge DAG, if one has, into multiple small ones with closed context is not to have a single point of failure. Again, with it, we can have optimized and dedicated resources. We can have even specific library versions or just upgrade one or downgrade another with zero impact in other jobs or in other DAGs. And, well, because we are a data-driven company and we want to solidify even more this statement, and our product architecture is based on microservices and external tooling, we as a data engineering team need to take all that into account to ensure a pipeline that is easy to maintain, that can be actually improved by any other team, and, well, by us, of course, and that is robust enough to provide data in a scalable and high quality way. Okay, so this takes us to the motivation of having to effectively manage the cross-DAG dependency in Airflow. So as we said, our whole pipeline involves around 100 DAGs, which some have the responsibility to extract data from a source, a PostgreDB, a MongoDB, or an external API service, and load it into our data lake. Other DAGs, however, are responsible for transforming that already loaded data. That means saving it in a new file format or applying naming conventions or just adding general metrics to enrich it. And, well, finally, there are business modeling flow DAGs that take that transformed data and shape it in a way that insights can be generated to support the decision making. So if it sounds a pretty straightforward data pipeline, well, it's because it is. However, the interconnection between all those DAGs is kind of the tricky part. Let me explain with an example. Let's say here we have to load a fact table of a star schema or a snowflake schema. And that fact table depends primarily on three sources. Let's call them S1, S2, and S3. So S1 is a MySQL database that contains user data, like from a registration feature in your app. And we can extract its data at midnight to have a D-1 processing. Source 2, on the other hand, is a SAP HANA that needs to internally consolidate D-1 data first before having it extracted for, foundation purposes. So our DAG needs to execute at, let's say, 7 a.m. Finally, source 3 is just another Postgre database containing transactions made from users. But since other models use raw and consolidated data from the source, there is a need to for adding an enrichment step to this flow. So as you all can see, managing those dependencies needs some kind of caution and a well-orchestrated pipeline in order not only to ensure data will be promptly available, but also to allow an even more complex scenario with almost 100 DAGs or 1,000 DAGs or 10,000 DAGs. To overcome this challenge, we've started to run some spikes by digging into Airflow code base, online articles, and even the Slack community, as well as internally brainstorming in order to have a better understanding of the requirements and the already existing solutions. All that to mitigate the risks as early as possible and to increase the reliability of the yet to come final solution. And to share with you all some of the ideas we came up with, let's go back to the fact table example. So the first option we had, and quite a straightforward one actually, was to put everything into one big DAG. This is pretty much easy to accomplish. I mean, we need only one DAG file, one schedule interval in the centralized task flow, meaning that we just need to set the downstreams between those tasks, right? However, we also see the cons of the solution. I mean, first, in order to have the fact table updated with, let's say, source 2 data, the start time needs to be at 7 a.m., tight coupling with source 1 and source 3, which kind of don't require this late extraction. Second, there are multiple contexts inside this one big DAG that kind of represents a soon-to-be huge monolith. And third, there's a single point of failure, meaning that we need a single code repository, we need same libraries and same resources. That actually poses a challenge to locally optimize for each source or step in this pipeline. Okay, so with that, we go to the second option, which involves defining one DAG per source, which not only eliminates the first con of the previous solution, because now we have specific start times, but also challenges the third one by allowing separate code definitions. We may even use other repositories, and we can have dedicated library requirements and dedicated node resources. The one con, though, that arises here is the necessity of manually setting the start time for each DAG. Well, for 1 or 2 DAGs, maybe we can pull it out, but with around 100 DAGs, things start to get a little bit chaotic. For example, when a DAG will land its execution so another can start, or what if the first one takes 5 minutes longer to finish because more data needs to be processed? And what if one DAG runs into an error I mean, how to ensure other dependencies won't just blindly execute. That's why we have a third possible option, triggers. So binding up with the second solution, where we have closed context DAGs, Airflow provides us with a trigger DAG run operator, which we all know will queue an execution. So for a DAG depending on just another, it works perfectly. But how would that work in our effective scenario? Let's raise a couple questions. So first, where would the trigger go? Since source 2 is the latest extraction, logic kind of points to it, right? Okay, so we've stated that the last task of the source 2 will downstream a trigger operator. Good. But there is another question. What if there's a source 4 that would run at, let's say, 8 a.m.? Well, that requires a constant monitoring of dependencies and trigger updates. And kind of just to add more complications to it, what if source 1 fails? We would need to rerun the entire pipeline or somehow add the XCOM feature in the equation? Um, up to this point, I mean, we've seen that there are not easy answers of some of those questions, and I'm sure we all have faced some or all of those challenges and have come up with different and well-designed approaches to solve most of them. So now we'd like to share QuintoAndar's approach to handle those cross-DAG dependencies in an effective way. Lucas, you're up.
Okay. Thank you, Ribaldo. So let's see now the chosen solution. Well, there's a known software engineering design pattern that suggests us to use a third-party component to manage the object's dependencies. So this design pattern, called Mediator, helps us to reduce the chaotic dependencies between the objects by handling them indirectly. So we could look at this example. Instead of each driver telling the others when to continue or stop, it has a traffic light that constantly stops or lets the drivers continue their way. That said, bringing this to our case, we could force the DAGs to only communicate through the mediator component too, and use the mediator to stop or start the DAGs instead of having each DAG triggering another. Well, we'll make this more clear in next slides. So in our solution, the mediator is a concept of an independent process that handles the DAGs triggering according to their dependence. Uh, we can think about it as a scheduler process alternative, specifically for triggering DAGs without fixed schedules. The mediator concept was implemented using an Airflow DAG in this first version. However, we shouldn't think about it properly as a DAG, but as a process that is using the Airflow's DAG features, okay? And as Ribaldo said, we have a pipeline that is implemented through different DAGs according to their context. For example, here we have the DAGs that do some extractions, and after we have, for example, the enrichment transformations and the modeling in separate DAGs. The enrichment of one context can demand data from another, so we have dependence here, the cross dependence here. The same will happen for the modeling DAGs too. And we need this cross-DAG dependence to be resolved effectively. Mentally calculate the DAG schedules and set it manually would be a very difficult task. Huh? But with Mediator, it's quite simple because it will automatically handle execution checks and trigger the DAGs for us. Okay, in this scenario, we will classify the elements in two categories as a dependence or a dependent. For example, let's take these two DAGs here, where the house modeling DAG depends on the house extraction DAG. So we will call the house modeling DAG dependent and the house extraction DAG dependency. Okay, the same for the second example. And a DAG can both be dependent and dependence, like you can observe in this another case with the tenant enrichment DAG. This tenant enrichment DAG is the dependence of the two modeling DAGs and is dependent of the tenant extraction DAG. Okay, but and if you don't want to wait for the whole DAG to be executed, and you don't need to actually, you can set the dependence in a single task or subdag, as it was done here in this tenant enrichment DAG. The task 1 is the dependence of the housing modeling DAG, and the task 2, the dependence of the tenant modeling DAG. It's pretty flexible because the mediator doesn't need to wait for the whole DAG to finish, but it will trigger the dependent as soon as the specified task is successfully finished. As you guys can see, the dependent will always be a DAG, and this DAG doesn't need to have a schedule because they will be manually triggered by mediator. Okay, so let's see a big picture of this orchestration and how the mediator interacts with these DAGs. Let's continue with our example case in which the housing modeling DAG can only run after the house extraction DAG. Runs. And now we have the visit modeling DAG that can only run after the visits extraction DAG has run. The mediator will handle this verification for us. I mean, it will check whether the house extraction DAG has successfully finished and will trigger the modeling DAG. The same will happen for the visits extraction DAG, but in this case, this DAG has failed, and the visit modeling won't be triggered. To handle these triggerings, the mediator has a custom sensor and a custom trigger that it has a custom sensor and a custom trigger, and on each execution of the mediator DAG, each sensor evaluates the dependence and makes the decision between to let the triggers execute or skip them. In this example, we can see that the visits modeling DAG trigger was skipped because the dependence was not good for the dependent run. Okay, good. Let's jump now in more details of how this works. For the dependency declarations, we have an YAML file called dependency.yaml in which we declare the dependency for each DAG. Basically, we define a graph in here. So you can see that for each DAG, we have the dependent DAG ID as the key and a list of dependency IDs. Remembering that the dependencies can be a mix of DAG, subDAG, and tasks. As we just saw in previous slides, the house modeling DAG depends on the entire visits extraction DAG, and in the task 1 of the tenants extraction DAG. Good. And this dependence will be read and parsed by the custom sensor that will make some validations, like if the DAG and tasks from dependency files exist, and raise some errors if they don't, so we can easily monitor that. It will evaluate the constraints to decide whether to trigger or not. We'll see more about it in next slides. It will also skip invalid triggers, as we also saw. And finally, it will save the triggers metadata into an XCOM. The sensor writes the supposed execution date of the triggered DAG into an XCOM in a JSON format. So the trigger will use this information and set the right DAG execution date when triggering the DAG. This way, the DAG, the trigger DAG, will have the execution date based on its dependence. And this will help us to track the executions if we need to monitor something in the future. After the evaluations are done, if the DAG trigger was not skipped by the sensor, the respective custom trigger will run, and we decided to build a custom trigger to encapsulate the behavior of fetching that XCOM metadata that I just saw, I just showed. And as I said, this custom trigger will set the DAG's expected execution date based on the information of that XCOM. And it will have one trigger per dependent DAG. Okay, the sensor will evaluate the dependency status against some constraints. We see only major constraints here because of the time limit we have, but we can definitely talk more about it in Slack after this talk. In essence, the sensor checks the last execution of the dependency and compares it with the last execution of the dependent DAG. In our example, if the house extraction DAG has executed today and finished it successfully, then the mediator triggers the house modeling DAG with the same date of its dependency, like in the example. Okay. On the other hand, if the house extraction had failed, then the house modeling wouldn't be triggered, of course. So someone of the team would fix the problem and, would manually rerun the DAG. Let's say that for this time the DAG has successfully finished. So the next time that Mediator runs, it will find that the DAG has successfully finished and it will trigger a new execution of the house modeling DAG. Okay. The rules go more complex than that, especially when talking about DAGs reruns, backfilling, and we can cover that in Slack if someone got interested. Good. Since you have a graph declared in the dependency YAML file, we can see it through an Airflow DAG. And we did that as a quick solution to visually identify the dependency among those DAGs. With this, we have a quick visualization of the data lineage among those DAG cross dependencies. Okay. Well, we wanted to validate the idea of having a third-part component mediating the DAGs starting in our pipeline. We think that the mediator is working fine for the needs of our company, and we expect it to handle much more DAGs than we have today. And also, if we think abroad, beyond our actual requirements, there are some things to be improved, like Mediator doesn't see the backfill executions today. So it's okay for us for now, but if someone needs to retrigger a DAG based on past executions, for example, so it needs to be implemented yet, this feature. Also, the mediator doesn't work well with dependencies that don't have daily schedules. I mean, like dependencies that execute once per week or per month. Almost all of our DAGs in our company have daily schedules, so it's okay for us for now, but it's a necessary improvement too. And what about having this feature built natively inside scalar constraints? For example, Scalar parses the DAG scheduling and takes in consideration many constraints and before creating a new DAG run or sending a task to creating a task in task instance database table. So what about adding these DAG dependency requirements at this moment? Well, it's a thought we have in a suggestion, and we can definitely talk more about it with the community and make some tests. But guys, it is it. This is a little of our mediator solution, and I will let Ribaldo conclude. It's up to you, Ribaldo.
All right. Thanks very much, Lucas. As we all know, data pipeline is not a new concept. We've been doing it for quite a while now. And despite having a great and well-defined theory, the usage of tools and the specificities and personalization of each implementation may and mostly will vary from company to company, right? So we have specific requirements and a handful of resources available, and most important, a different set of skills that pull us towards great solutions. And well, for us, it's the mediator. With it, our data pipeline has become more parallelized. Once tags aren't executed at a fixed time, it has become more scalable in a way that more tags can be added without sweat. Has become easier to maintain because everything has its own context, requirements, and constraints. And actually has become faster by quickly transitioning to other steps, other tasks. Um, well, in a way, the mediator is helping us reduce this, I would say, chaotic dependence management by restricting the direct communication between DAGs, by decreasing the coupling between steps in our pipeline that are, of course, represented by multiple DAGs, and also by forcing them to collaborate via a single point. But well, of course, not all are roses. We understand that this mediator could become a god object that does too much by controlling everything. But as Lucas said, we still have some tweaks to make, some improvements, and maybe a built-in implementation. So our solution really evolves to a greater one. Um, well, we hope you guys enjoyed it. Lucas and I certainly had a blast. Thank you very much. And well, we can go to the Q&A.
All right. Thank you both so much. I know that I have questions, and I'm sure other folks do too. While I wait for those questions to propagate into our side of the tool, I'll ask you my two questions, but I would like to disclose to the audience that I do work for Google and I work with Cloud Composer, so I'm super biased.
Yeah.
I wanted to know how long you've been using Composer and why you chose Composer versus managing your own Airflow instance.
Okay, great. Yeah, great question. I mean, we've been using Composer for more than 1 year now. I suppose. Yeah. I mean, first we started managing our own Airflow instances, but we kind of find it like hard to maintain everything. And Composer just do everything for us. We just have to click on a button to create an environment. So it's kind of pretty easy for us.
Cool. I know a lot of folks have done that path of managing their own to then wanting it managed. And I also know it's not for everyone, so I want to be respectful. But obviously, I'm a very
Totally.
biased, huge fan.
No,
Um,
yeah, I mean, because just to add more to it, I mean, we kind of wanted to focus more on the orchestration itself.
sure.
So we didn't have to take into account like managing instances and connections and or anything.
Absolutely. All right. We do have a question from the audience. Someone would like to know, can you elaborate on the custom sensor you built for the mediator, and how does it pool the sub-DAGs for their status?
Well, when it receives the dependency, we have that dependency YAML file that I showed you. Uh, it will take the dependency there and you treat the subdags as tasks, and it will better as it will pull the tasks status in Airflow database. It will also pull the subdag status as it will also pulls the DAGs status. So it's like the other elements, the other entities. We just combine all the status of dependence after all is done. Do you think it's good, Ribaldo?
If you need more clarification too for the asker, definitely follow up in Slack.
Sure.
But sorry, if you want to keep going.
No, yeah, but just to add more to it, also, we actually run some queries on the database, as Lucas said, and we kind of um, don't need to know if it's a task or if it's a DAG because we have everything in the YAML file. So we just look for them in the database. Yeah.
Awesome. I asked my other speaker today, do you have a favorite Airflow operator?
Wow, that's a tough question. um, I would say I'm not gonna say the sensor, not to be biased, but because of the mediator solution. Uh,
You can be
but
biased.
okay, so yeah, I'd say sensor. Yeah.
Cool. All right. We actually have a couple of questions in the Slack. How do you solve for a single point of failure in the case of the mediator?
Okay, yeah, great. So instead of let's say we're deploying a new code, and that code is all closed in one DAG file. If there's an error, or if you accidentally deploy a bad code, all all that DAG, the entire DAG will actually not be executed, and we kind of won't have the entire pipeline, or actually some part of the pipeline run. So if you have like separate DAGs and separate triggers and separate scheduling intervals, then we can not only use that into our advantage to like micromanage everything, but also, as we said, we can have specific resources, we can have specific libraries that actually help us scale up or scale down any other DAG.
Sure. Okay. Another question related to that. How does the mediator compare with the approach of having sensors on the source data availability, like S3 sensors, etc.?
Lucas, you want to take that?
Okay. Um, but having the mediator uh, managing that as a separated component, we think it was more organized, right, Ribaldo? And because it, like Ribaldo showed, if you have, if I understand the question, if you have those sensors in the sources, in the DAGs, in the source DAGs, we could have some problems of dependency too, like Ribaldo showed in his slide. So having this sensor separated in a DAG, because we use this resource that executes separated, we thought it was better to manage the dependency. Ribaldo can add if you want. So if I understood the question, we thought it was better.
Yeah, no, totally. I see two things here. First is, as Lucas said, we can have like a single source where we look at all the dependencies, just not not split into S3 or other sources, but also we can have a visual of how the data lineage is being built. So of course, we can use S3 sensors, or like trigger lambdas, or anything, but we thought that keeping it inside Airflow would gives us more flexibility. And actually, we had already that know-how of building everything. And since we find the DAG visualization kind of pretty, we went for it.
And Ribaldo, just adding, this is a solution we built to validate the idea, right? So we have one sensor and one custom sensor that we built that checks on database, the metadata database. But what about if we had another requirement? So we had to check directly in some S3 to check some data using another sensor. Don't know, maybe we could enhance this mediator with some new features, some new type of sensors, and complementing also the first question about the single point of failure. What about if you need to separate the mediator in different mediators by context of DAGs? Could be too.